The Newburgh Museum speaking series continues with certified petroleum geologist Ralph Baker, introducing the museum's June into December exhibit, Newburgh Rocks.
I was born in Germany. I was raised in New Jersey. I lived most of my life in Texas. And now I'm standing here and I'm going to tell you all about Indiana geology. So we're going to try. Welcome. We live in a very interesting little community here on the Ohio River. You can see us right here on the top of the bend. If you look around the corner here, you can see Evansville in the background. What I'm going to try to do this afternoon is to talk a little bit about where we came from, all the way from the beginning of time up and through the latest economic developments and that sort of a thing here. So, a quick tour. We'll talk a little bit about the Earth's origin, the actual basic structure of the Earth, the kind of rocks we're built on, how those rocks eroded and evolved through time, the different layers of rocks, the environmental increments that they represent, the fossils that occur in those rocks, and then later on the modification through the ice ages and the glaciers and the Ohio River. Ultimately, these have all affected the economy of Newburgh. And finally, we'll take a look at the early inhabitants at Angel Mounds, the archaeology, the different cultures that lived there at that time. So this is the beginning. I challenge you to find any presentations that start earlier than this. Yeah. You can go back to, I guess, Einstein and the Big Bang Theory. Of course, various religions have various ideas on how these initially began. But at least the scientific data suggests that the universe began about 13.8 billion years ago. What was there before then? What's going to be here 13.8 million years from now? Nobody really knows the answer to that. But in any case, the universe is made up of millions and millions, as Carl Sagan used to say, of galaxies. The one we're most familiar with is the Milky Way. Each of those galaxies has a countless number of solar systems. The solar system means you have a central star, and around this central star you have planets developing. What happened was you have this primordial nebulous of extremely hot gases. They start to cool gradually. The cooling condenses into a central sun. The planets are little bits of matter that have evolved from the sun, have spun around. They're attracted by the gravitational attraction of the central sun, and they form the planets. And the planet that we're most interested in is the Earth, which, again, by scientific data, looks like it's been around about 4.5 million years. So we've gone from the sun into the individual planets. As the planet cools, the lighter materials tend to form a crust around the outside. This is silica-rich. These are the aluminum, the silicates. The heavier irons and nickels tend to congregate into the middle. Now, as the material is heated, it comes up, it expands, it comes up to the surface, it cools, and then it condenses, and it wants to drop back down again. So we have a series of convection currents, and these convection currents move these plates around. Think of it as an eggshell. You have the crust here, you have this convection internally, and then at the zones of weakness around the margins of these, the plates themselves will tend to move and shift around. In some places they're spreading apart, and in other places they're coming together. And when they come together, they either override or underride each other, or they create folds. Here's North America. You can see Florida there, and we're just about here. Now take this spheroid here, this globe view, and translate it into a map view that we have here. And you can see North America. Here's Indiana here. And this is the North American plate, and here is the Pacific plate. The North American plate, you have the mid-Atlantic ridge here, and it is pushing it to the west here. The Pacific plate wants to push to the east. So what that has done is it set up two major ranges of mountains. First are the Appalachian Mountains here in the east. You can see there's not very much left of these. These are very, very old, have been eroded. This was in the Paleozoic times, which is hundreds of millions of years ago, and we're going to talk about that in a moment. The Rocky Mountains are, during Cretaceous time, they are much younger, and so they haven't been eroded quite as much as the others. But what you have in the middle now, you've got one upfold here, you have a down warp here, and you have the higher Rocky Mountains over here. Indiana sits right about in the middle of this, so we're in a relatively calm part of the continent. So once in a while we're going to have a word slide, but I need to do that just to get you involved and make sure we do some science here too. We've talked about the molten earth. The earth cools. They're floating on these plates. They're called tectonic plates. The word tectonic simply means dynamic or moving. Here, at the edges of these plates, you have a series of volcanoes. That's the weakest zone when the hot materials from within the earth tend to come up to the surface. Here, they form volcanoes. When the volcanoes start to erupt, you're getting several kinds of gases, carbon dioxide, water vapor especially. And as those gases cool, they develop the early atmosphere, and of course you start with the rain then. So we've gone from a molten earth, the plates, volcanics, and volcanoes at the plate edges, develops into an early atmosphere, and the rains begin. As the rains began, the streams developed, eroded the lands, and the sediments that were eroded from the land surfaces filled these either shallow lakes or the ocean basins here, the marine basins. Scientific thinking seems to conclude that life has evolved in the seas. There's a famous picture somewhere that shows the first amphibian with fins and little legs that's coming from offshore and marching up onto the land. So in any case, land saw the development of forms of life. So between the life that's in the land and in the water, you start to develop a sequence of layers. Some have got biological material in them, others have got just the clastic debris, the rock fragments and so on. So you're building up the rock layers and that's called strata itself. So once we have all of these things developed, the earth dynamics, continuing earthquakes, finally weather, glacial events, they shape the continents, so they take the form that we see today. So from this molten material, we get various kinds of things coming up. The minerals are fixed chemical compounds. If they have facets on them, if they're solid, then they form crystals here. You've got the types of minerals here. You have the forms of crystals in this area here, and you take different kinds of minerals, they bond chemically, and they form rocks here. Now in Indiana, most of the rocks that we're looking at are sedimentary here. Where we are, they're about 200 million to 500 million years old here. So these are pretty old rocks that you're looking at here. The three major kinds of rocks we have here are what they call the siliciclastics. These are little grains of pre-existing rocks that are cemented together and form the sandstones and the shales and those kinds of things that we're familiar with. Additionally, we have carbonates. These are of biological origin. These are from fish bones, little microscopic particles, mainly calcium carbonate, and they form into thick layers of limestone, which you'll see becomes very important here in Indiana. Here, another important type of rock here are the carbonaceous or carbon-rich rocks. And these are developed from land plants, and they eventually form the coal seams that we have in this part of the world. And finally, there are the crystalline rocks here. These are very microscopic crystals. They either precipitate out of groundwater or are chemical replacements. One element replaces another. And this is where we have the cherts and the flints that were used by our native cultures to make arrowheads and that sort of a thing. So the three major rock types, igneous rocks. If you drill down far enough in Indiana, you're going to eventually get into some igneous rocks here, although none are exposed, at least in this part of the state. Here, there are two kinds of those. One comes from the central magma chamber here. It's more easily under the great pressure here. It comes up to the surface, it erupts. It cools very rapidly, and so the crystals are very small. In the magma chamber here, the magma gets to some higher level where it's trapped. The rocks cool more slowly, and the crystals have a chance to grow larger. And so you have the coarser grain rocks here. These are like the granites. And up here you've got the volcanic products, which are basalts and other kinds of rocks like that here. So those are the igneous rocks. The sedimentary rocks we've already talked about a little bit. These are the particles that form layers. The colors are different because they have a different chemical composition. The environments change, the waters get deeper or they get shallower, or you may have a very dry spell, and so different kinds of organisms thrive and different kinds of rocks are formed. And so the lighter colors have more limestone in them, more calcium carbonate. The darker colors may have more iron content. And you'll see the difference in the resistance of the rocks. If you have either a better cemented rock, you will get the more resistant layers, and as these erode, they tend to stick out. If you have the softer rocks that are made up of shales or clays, they erode out more quickly, and they're recessive. They tend to eat away into the rock itself, so you get this nice pattern here. This is just a sandstone that's had wind blowing this very, very fine material from different directions. It erodes out. At one time, there was a lot of flooding and water activity here, and you get these very nice but very thinly layered rocks here. And they're both sedimentary rock layers here. So third kind of rock, technically it is a third kind of rock, but all it is an altered form of the other two kinds of rocks that we've just talked about. And these are metamorphics here. If you look at your countertops, you say, well, I've got granite. Well, it's not necessarily granite. If it's banded like this, it was granite at one time, but under great heat and pressure and some of these earth dynamics that we've talked about, all of these layers were at one time parallel and very level. But because of the heat and the pressure, they've come together, they've crumpled up, and you get the patterns that you see here. And similarly, a granite under great heat and pressure will turn into a sandstone into a quartzite. You know what marble is. You go from your limestones here into the marble, and eventually you can go from clay into slate. And for a little bit of fun here, you have your plants in your backyard. They become buried under low oxygen conditions. They turn into coal. Eventually, as the very high heat and pressure continue, they turn into carbon and graphite, and if you wait 100 million years, it might even turn into diamond down there. So you never know. Okay, the first aspect that we're going to look at is the actual structural geology. This is the interest there is in the actual configuration of the Earth, again generated by the folds and the faults and so on that are caused by the movement of the plates. Where the compression occurs, we said before, we have the mountain ranges here. To the west we have the Rocky Mountains, to the east we have the Appalachians, and in between we have several basins. The one we're most familiar with is the Illinois Basin here. And through time these are modified by volcanoes and earthquakes, and then the topography is modified by erosion, the ice ages, glaciers, and those kinds of things. This is a very good book I recommend to you, The Roadside Geology of Indiana, Camp and Richardson. And this is a little cartoon that illustrates a typical look at the Indiana landscape here. You have very thick layers of limestone. The caves develop in them. We'll talk about that in a little bit. You have various types of sandstones and shales. These are little fossils here that are developing some of these. So if you would take a drill core, you would drill through this stuff and you would come up with what's called a stratigraphic column. We go back to the tectonics and the movement of the plates, and there was an article in the Evansville newspaper recently that talked about, are we going to have earthquakes in this area again? Well, we all know, or if you've read the article here, that in New Madrid we had a major earthquake, bigger than the San Francisco quake. This particular one occurred between 1811 and 1812. Here is Nashville, Tennessee. Here is the area affected by the New Madrid earthquake. The shaking was extreme where the darker colors are, and there was progressively less shaking, but it was noticeable and perhaps damaging. Back in 1811, obviously we didn't have the infrastructure that we have here today. So where we are now, up through and past Nashville over here, we still had very strong to strong shaking going on here. Are we going to get one in Evansville? Well, this is the U.S. Geological Survey published this geologic map. And what we're seeing here are not only the different kinds of rocks, which we'll talk about in the middle, the concept of geologic maps, but also a mapping of the faults here. The faults are breaks in the rock. And you can see Newburgh is right about here. This is Evansville. And there are a major series of faults to the south and the west of us. Here's Paducah, Kentucky. And that gets progressively closer to the New Madrid zone here that we have there. If we follow the science, here's Evansville, Newburgh over here. You can see that we're very close to a second seismic zone. This is the Wabash Valley zone here. Most of the faults that you just saw in the previous slide were from the Wabash Valley fault zone. There's something called the Rough Creek Graben, which is basically where the rocks have split apart and this graben structure has fallen down. And of course, a little bit down to the further south and to the west, you have the New Madrid zone there. So we do lie somewhat near the major seismic zones there. We do have a continuing record of earthquake activity all the way from New Madrid times, and that's when they began keeping records, actually. So prior to that, there were certainly additional events, but we just weren't paying attention then. The geological maps show that there are some active fault systems, but not exactly where we are. So there's a small chance, but I'm pretty confident that you're not going to get the big one here. Now, having said that, we sold a property in Victoria, and we had to have earthquake strapping around the water heater. So the state, at least, is concerned about the possibility of that sort of a thing going on. So the primary tool that a geologist uses is just a planar map, a map of the surface. So if you were standing at a given location, in this case, we'll go back to Newburgh here, and if you drilled straight down, you get through the soil, you would get into layers of rock that are from 300 million years old to the west to approximately 500 million years old to the east here. And we're in a shallow bowl. And if you think of these as a series of concentric basins here, the youngest rocks are what's called the Pennsylvanian Age here. They're in the middle. They get progressively older as you go outward all the way to the Ordovician period, which is the lower Paleozoic time here. So you're going from 300 million years old to 500 million years old here. And each of these trends continue into Kentucky and into Illinois and eventually form this large basin. Now, this is a very generalized look, and that's fine for these kinds of activities here, where you're trying to, plan a major pipeline route or interstate highway system or such. Behind this, we see a more detailed geologic map here. This is Warren County and Spencer County. I didn't quite catch Newburgh down here, but this tells you from land surveys the details of the different kinds of rocks and the characteristics of those rocks. Now, to really look at what's going on, we have these highway maps that were published by Richardson and Clark, the book I showed you before. And if we look here, this is Newburgh, and very close to where we are, you see shallow lake deposits. These are all from the glaciers, which came down, and we'll look at that in a little while. We have an outwash plain, again, from these glaciers. The Ohio River and the Wabash River are two what they call meltwater streams. From the ice ages about 14,000 years ago, as the ice melted and receded, the water was captured by these streams, which eventually turned into the Ohio River and the Wabash River over here. And these are just the different types of materials that were left behind by the glaciers. So those were the geologic maps. As far as a geologic cross-section goes, if you have enough either deep mining or road cuts or drill cores, you can get a look at the sequence of the rocks vertically through time. So this is a slice much as you would see here in a cake, where this is the recent layer up here is the frosting. The first layer that was put down is way here on the bottom, and it gets progressively younger as you go up through time. This cross-section is just a very small part of the Illinois basin that we're a part of. Here, it goes from the Pennsylvanian rocks through the Mississippian, through the Devonian, Silurian, all the way down here. So if you were standing in Indiana on the western side of the state, you would see the youngest rocks, or the Pennsylvania rocks. And if you proceed to the east toward Louisville, the falls of the Ohio, you would get into the much older rocks, the Ordovician and Devonian rocks there. And I understand there's a very nice fossil locality there. So this is the boundary between Illinois and this is Indiana here. And so we're roughly in this basin here. Now it's called a basin, which is roughly the generalized shape that you see here. But within that basin are wrinkles. And if it's a simple fold, then it's called an anticline, and this will eventually come over the top here. You can see an arch on that side. And to the east, we have a series of smaller anticlines here, which are called an anticlinorium, which is simply a term for a series of smaller folds here. All of these are cores, or drill cores. The rocks were sampled, the depths were noted, and then from a series of these data points, they put together this cross-section of the basin itself. Here. Some of the interesting things that we find in Indiana and that we have on display here in the museum are geodes. Geodes are vacant cavities in rocks which fill in. You have groundwater traveling through, you have a void in the middle, and you get different elements precipitating out of the matrix itself. If the geoid isn't very old, you get fairly small crystals. It doesn't have a lot of time to grow within there, and you might not have very much space. As the groundwater precipitates the materials, it progressively changes composition because certain elements are leaching out and others are still present. And the colors represent the different types of elements that are present here. These are iron oxides would be here. This would be either manganese and magnesium, other kinds of minerals too. And you can see the crystals growing inward from here. If the cavity is larger and if the crystals have more time to grow, then they become bigger, they're better formed. And we have an example of one of those there in the corner. The purple color here is caused by manganese. That's found in very, very small quantities between. The Hoosier National Forest apparently is famous for having a bunch of these here. You pull them out of lake beds and out of sedimentary rocks. We have some courtesy of the Krantz brothers. Here's one of the local chickens here, used to laying eggs, but taking a look here and wondering how on earth, a chicken laid one of those. Wasn't quite sure how it happened. We have several of these that are unbroken. We've opened up a couple, and you have the mineral infilling, and you've got the crystals growing inside there. Yeah. Something that becomes more important as we get into the economic aspects of this, both the coal and the oil and gas. Here, we'll take a look at some of the local fossils here. USI has provided us with a suite of fossils that will show up in the case that we see over here. The different kinds of rocks that give us these fossils are the very thick limestones here, and they generally, the fossils occur in the shallow seas, the coral reefs and marine shells. We have the shales and the coal beds, and there are primarily land plants, trees, ferns, that sort of a thing. Very few fossils occur in sandstone because the sandstone represents a fairly high energy environment. And if you have an organism that's fallen to the bottom and is dying, it gets disturbed and destroyed very quickly if you have fast-moving water. So it takes a very calm environment, the deposition of clay, and something to preserve the fossil there. But some of those sturdy fossils represent mammoths or horses or even dinosaurs, although there are none here in Indiana, at least none that have been discovered so far. Much more recently, during the ice ages, we have the Brea Tar Pits. They have all these saber-toothed tigers that fell into these tar pits. They were buried in the tar, and the tar had kept the oxygen out, and the animals themselves were preserved. Then, of course, during human history, during Roman times, we had Mount Vesuvius. And some of you have seen the books that show the actual volcanic ash that surrounded human beings and animals and that kind of a thing that's preserved. And all of those are fossils, basically, that have been preserved. Petrified wood occurs in Indiana, in any case, sandstone that's 320 million years old here. This is where we have the cellulose of the tree, the actual cell structure of the wood being replaced with silica. You've got groundwater moving through. The silica fills the pores in the wood. Eventually the organic material rots away, and you leave with a very dramatic looking ring. Now that's not from Indiana. We do have some specimens that are about 300 million years old in the case over here that are specifically from Indiana. And look again, you see that these shades of color, if they're greenish, you've got the chromium, cobalt, copper. The yellows may be manganese oxides or iron oxides here, and the purple is generally manganese here. So you can take a slab of this and get some idea of what the chemistry is, the chemical composition here. Fossils are formed, seashell dies, and it's either broken up and the little fragments dissipated and they form part of the sediment. They found seashell fossils at tens of thousands of feet up, and everyone scratched their head. What are seashells doing up this high? Well, the answer is it was one time a shallow sea, and then at some point the entire strata was consolidated and uplifted and eroded off here. So some of the early observations led us to our current understanding of how these earth processes work. If you were in Newburgh 320 million years ago, this is what the land would have looked like here. It's not really the Ohio River, but this is a shallow part of the sea. Here we have a reptile sticking his head up here. These are Lepidodendra here, these trees, and of course the ferns. We have examples of this in our fossil case. And so very marshy, still not very hospitable environment here. But all of these would eventually die. They would fall into the mud, become buried. They would become oxygen starved and eventually find their way into the coal layers that we see today. So in terms of the economic influences here and how geology has influenced that, we have two distinct periods here. One is the recent past, the ice ages, where we have the glaciers that came down as far as, say, Posey County. They've receded. The Wabash and the Ohio rivers carried the meltwater off and formed the rivers as we see them today, draining into the Mississippi. This led to our fertile valleys and the extensive agriculture we have here. It became a communication pathway for the expansion of the settlers traveling from the East Coast to the West, fur traders, anybody who was able to go up and down the river. And of course, today we have the modern shipping. In terms of Newburgh, because of our topography, where we live in an area where we have terraces built up, which was once the level of the Ohio River. It's now eroded down through, and it's left these terraces up above. Well, you had coal nearby. The terraces provided enough elevation so that we didn't really flood here, and so it was a good place to build a settlement. The steamboats would stop. They would spend money in the local saloons and hotels and all those kinds of things. The sand and the gravel deposits from the receding glaciers were very important in terms of even our present day economy here. You've got the Mulzer Works just to the west of town here. The clay itself, we had our very own pottery here in Newburgh, the Engel pottery. We have a whole case full of them there. The famous Yule pottery and different types of stoneware here, up and through whiteware. So that's the recent past. These are the ice ages, and very, very important to the regional economy, the local economy. If we go back into the Paleozoic era, about 320 million years ago, we had the development of the coal fields that we just talked about. The coal supplied both local industries, and I understand some was reserved for export as well. So a lot of money into the economy. These are basically, I think, in order of economic value here. We are in the Illinois Basin, part of the extensive mid-continental oil province here. That today we're basically, it's not as productive as it was several years ago, and that's because of the technology. A lot of the oil is still there, but it's more expensive to extract from the ground than it was. The limestone quarries, the building stone that provided material for the Empire State Building, the Pentagon, many famous things like that. To a lesser degree, but still important, the caves provide tourism dollars. They come in all the way throughout Indiana and down into Kentucky. And within the caves are these precipitated materials like the chert and the flint, here, which the Indians used to produce their arrowheads, and saltpeter for gunpowder, and that was especially important during the Civil War. Here, bat guano, that sort of a thing. So as far as the glaciers went, what you see in the hatchet blue was not glaciated. This was basically the bedrock. All of the yellow that you see here, these are all sand and gravel deposits. These are lake deposits. These are very shallow lakes that as the glaciers were receding, the ice would dam up some of the streams that would form shallow lakes. The lakes over tens of thousands of years would build up sediments in them, and those are the deposits that we see today. A lot of the clay comes from those sorts of things there. And all along the river here, as the course of the Ohio has changed through time, we've developed a series of river terraces. It's interesting that you can see how the river curves here. This is the faster moving side. This is the slower moving side. Where it moves faster, it's eroding the land and forming these terraces. These terraces don't exist on the other side of the river. On the Kentucky side of the river, the land is depositing. So in other words, this is moving northward. So the Kentuckians are gaining farmland here to the south, and we're losing buildable land up here to the north. But we don't worry about it in our lifetime. Coal, pretty much the economic driver for the entire area. The Sargent Coal Mine here was where the American Legion is today. This is Bell Road. This is State Street going up. Here is the shopping center where the Rose Hill Mine is. Here is the Sergeant Number 1 anyway. In this case, this is Sharon, and here's the American Legion. So all of this was mined, much of it underground, mined, which in some areas now causes subsidence problems. But I would recommend this book to you too. It's an extremely detailed history of all of the different coal mining activity in Warr County and so on. And this presents a problem for real estate developers. Some of these underground mines aren't very well mapped, and so you are building a house on you think it might be solid ground, but it's really not. Here. So we have coal for industry. We see these barges every time you go down to the riverfront. This is a reminder of the old steamboats that used to stop by. This one I'm sure has got diesel engines on it, and the smoke is just for show, as is the paddle wheel. But nonetheless, it's a reminder of the industrial purposes and the value to the economy. The coal gardens themselves are based on a recipe that I guess second graders used to do over the years. Coal is a very porous material, and if you add some certain chemicals to it, bluing agent, Mrs. Sargent's bluing agent, ammonia, salt, water, and I guess food coloring is the other one. We have a recipe in the other room here for those interested. Well, you mix the ingredients, you pour them onto the coal. The porous coal absorbs all the chemicals, and as the liquid evaporates, it forms these lovely crystals that you see here. So it's they become messy after a while. We've got a couple of them over there in the back here, but it's a neat project for the younger generation to do. Oil and gas, the red indicates the gas deposits, the green indicates the oil rather in Indiana. And again, this is pretty much, would extend into Illinois and down into Kentucky and perhaps further. There's the Trenton field up here, which is an outlier of some of the other oil and gas activity. Well, similar to the way coal had formed, we have maybe a wayward dinosaur, but primarily aquatic plants and animals, both in the freshwater and the marine environment. They eventually die and fall to the bottom, rich organic material. They become buried in the mud over a large amount of time. The progressive burial increases the heat and the pressure, and the organic materials turn into oil here. And you see some of the sandstone along the sides here. In order for the oil, which is lighter than water, it will tend to migrate uphill here. And the oil itself is slightly heavier than the gas. So the gas forms on top of the oil over here. So generally speaking, if the gas is present here, this might have been eroded off and not preserved. You generally need some kind of a seal, some kind of a clay, so it can't migrate through. And the oil well is drilled through here. First you would encounter gas, and then you encounter the oil under that here. Today, it's not that large a driver of the economy. Back in the 1890s, this is up in Wells County. This is what they look like, pretty rough and tumble. Here, wooden shacks. We've got some structures in the background, some primitive kinds of well drilling equipment there. This is a couple of oil tanks to the northeast of Boonville here. They have usually stripper wells that get roughly 5-10 barrels a day, and depending on the price of oil, it's either worth operating them or it's not.
There's a lot of water in it.
There's a lot of water in it, and sometimes you have to inject water to get the residual oil out of the rocks, and it's a major economic game. How much does it cost to do the drilling, to do the recovery? You have to transport, you have to store it, then you have to transport to a buyer. And so there's a lot of parts to that. Here is the bedrock here that was not glaciated. This is roughly the sand and gravel deposits here. Several have been abandoned, but you can look at the blue stars here. They're still actively collecting the sands and the gravels, and again, very important. This is such a low value commodity, it makes access to the Ohio River very important here. Here you have a crew of a couple of people moving that amount of sand and gravel. If you had to truck that in or transport it otherwise, it would be an awful lot more expensive. Some of you might notice that we're perpendicular to the Ohio River here. It's not moving up and down the river here. I took this picture, and what they will do occasionally is actually turn the barge tow, the entire string, entirely around to get from one side to the other. Not necessarily in this frame here, but sometimes they'll have general cargo on one side and a couple of these on the other. And for some reason, they have to. It's cheaper, more economic to turn this around, and then have one of these little utility tugs come out. They will disconnect one or two of these, whatever they need, and then take that over to the shore. So we've seen that a couple of times in our 4 years down there. Limestone is very important. I'd mentioned before that we're responsible for the building of the Pentagon and of the Empire State Building. It holds up very well to sculpture here. You can make very intricate sculptures out of it here. The Yule pottery, folks, the Engel pottery behind me, and some of the brick and tile manufacturing is also here in southern Indiana. There was several clay operations in Evansville. Some have moved to Huntingburg because the quality of the clay was better up there a little bit further to the north and to the east here. So all parts of the economy. Some of these thick limestones that we talked about form the caves. Here, this is the initial water table here. As the water penetrates through the cracks in the limestone, as the water level recedes, then we have these voids that open up, and the continuing drip of water precipitates out the calcium carbonate and other elements, and it forms these long stalactites heading downward here. And if they drip to the bottom, it forms the stalagmites heading up in the opposite direction. You get impressive looking structures like you see here, right? Back in the early days, it wasn't so pleasant for some people here. Some of you might remember that story here back in 1925, read about it, of course. Back in 1925, where there wasn't a lot of economic viability in central Kentucky except for these caves. And this particular individual, Floyd Collins, was trying to get rich, and he wound up stuck in this little place he couldn't get out of, and a rock came down and trapped his ankle. And where's Melissa? Melissa gave me the book and the story of this, and it's horrifying and fascinating at the same time here. So poor Floyd got stuck. Just for fun, I plotted up these caves here. These are the Blue Spring Caverns. Here's Lagodi over there, and Paoli is there. The Marengo Cave here, and sequential caves going down. You see this little, it looks like a Gigamagi sign or something. That's right here. So you're in the middle of this very thick band of limestone, and this, remember, this is a saucer, so this continues on to the south, and Mammoth Caverns are right about there here. So they're all on trend. So if you were a geologist looking for a new cave, what you would do is you would look along this trend somewhere here, because it's got exactly the same environment, and it could possibly be there. So feel bad for Floyd. One of the problems we have being so close to the river, of course, is this flooding, and this is where a very precise map is important in terms of building homes and industry and that kind of a thing here. Here again, this is Newburgh, and this is the alluvial plain of the Ohio River, mainly sands and gravels and so on. And these are the terraces that I talked about. This is one of the river terraces here. This is all natural. It's been armored by the Corps of Engineers to prevent the erosion. Here, this is the end of Water Street, and just to the west is a stream that comes down. And here's the same picture here. Here is the stream. And based on your elevation, you're either safe from flooding or you're not, up to a certain point here, up to a certain degree. So these kinds of maps are extremely important to be kept current, updated, and so on. Finally, we'll take a look at some of the Native American inhabitants. Here again is Newburgh, and we've had both the Delaware, and what's the other one?
Shawnee.
And the Shawnee is on here. Mike Linderman is one of our directors. He's the director out here at Angel Mounds, and I think he's going to talk to us next month. But we asked the question, were there any other Indian tribes in this area? And apparently not. Certainly bands of Indians passed through. Today you say Native Americans. They certainly passed through, but they were not organized into tribes, and they didn't stay for any particularly long length of time, except for the Angel Mounds culture that we'll see in a moment. This is a wonderful book. It may be politically incorrect today, however, it is extremely descriptive. It has fascinating insights, it has photographs, diagrams, and it's not written in a nasty way at all. We have fantastic war dances, mysterious medicine men, desperate Indian tortures of prisoners, daring deeds, and all these things here. And it's just a fascinating book here, and we actually have a copy of it back here somewhere. Looking at Angel Mounds, this is right in our backyard. Here we have a couple of junior archaeologists here that went to visit one day here, and lo and behold, right in their backyard is this entire civilization. The Angel Mounds culture was in place from about 1000 to 1400 AD. This is the site as it looks today. It was originally farmland after, of course, the Indians left. We have tried to recreate a Angel Mounds era campsite in the other room. I invite you to take a look at that a little bit later on. They would fish. They did some local agriculture, some hunting. They grew corn, those kinds of things. The mounds, when they were first discovered, well, they were described basically in the early 1930s, but the initial excavation began in about 1939 as part of the WPA program, getting people back to work during the day. But by that time, the farming that had gone on here had reduced many of these mounds to only a few feet above the surface. So God knows how much material was lost since then. The champion of all this was E.I. Lilly, who was head of the Indiana Historical Society and, of course, head of the pharmaceuticals company. And very graciously, he provided the funding to buy up this farmland from the Grimm family. And the excavation began. We have some information, some technical articles on the kinds of artifacts and the things found there. So unfortunately, many of the really priceless artifacts are up in Bloomington. IU paid to have the work done. They sent in their archaeologists and so on, and many of the artifacts are now in Bloomington. A lot of reproductions here at Angel Mounds in the museum, along with some original things as well. Here. Glenn Black worked around the same time E.I. Lilly did, and this is a very interesting quote. It should be remembered that a mound once dug is a mound destroyed. If the story it has to tell be lost on the initial attempt, it is lost forever. So this is why there's so much heartburn about people going out and digging up pottery and so on, because the context, the depth, the style, all of that is a very, very important thing. And once that's gone, it is lost. This is an excellent little book that talks all about the history of Angel Mounds, the excavations. It's illustrated, and we have a copy of that in the back as well. And we use that as a guide. So not only Angel Mounds, but the entire Ohio River Valley is very, very rich in Indian artifacts. We got these on loan from the Working Men's Institute in New Harmony through Ryan Rokicki, who's the director there. A variety of different blades and axe heads and so on, many of which are on display in the case over here. This gentleman is Jack Haskell here. He's a local collector, apparently very well known. And this is my other cousin, Mike Krantz, here in Boonville, holding up one of the very nicely done artifact displays that were put together by this gentleman over here, Rivas Campbell here. Rivas was born in 1897. He died in 2003. He had a shoe shop in Boonville. He was an auxiliary policeman, and he was a lifelong artifact collector. He would take his collections and build these beautiful displays illustrated with various paintings and photographs of other kinds of relics and so on. And he was collecting up until he died here. So that must have been good for him, all that fresh air. And we do have both of these on loan to us. And I invite you to take a look at those as well. So you can do your own artifact collecting. This is down by what's now the French Island Boat Club, I guess. It used to be the Boonville Boat Club. This is the extreme western end of it, little, I guess, a drainage ditch over here. So you go onto Google Earth, and you go through the little timeline, and you go back as far as you can. Now, this particular spot here is high. It's a high spot, which really doesn't show up so well. This is 2021 imagery here from Google Earth. If you look back to 1998, which is here, you can see a little lighter shade here. Well, the soil isn't quite as moist there. It's a little drier. So when the sunlight hits it, it has a little more reflectivity and it looks brighter on there. And this is a hot spot for looking for arrowheads here. It's topographically high. That was a campsite. It's within, just a few, maybe 100 feet, 100 yards of the river. And so you can see where the early streams were that don't necessarily show up today in the plowed fields, and that helps you get some idea of where this was. Number of publications that we use to research the talk today, as well as available to the interested observer here. And finally, just say rock on. These are fascinating little things, and if you find the right collection of rocks, that's what you will see there. So that's it. Thank you very much.